Okay, we'll continue our lecture on lists. So this was lists part 2. We left off on Friday. I hope you guys had a nice weekend, and we're back. So okay, let's. So I think I mentioned this, but lists are mutable, and what that means is that the objects can change themselves. Okay, so remember, variable names are object names in Python are pointers, and when you assign an object to a name, that name points to the object in memory. And what we can do is we can actually modify the object in memory. And so what I have here is this example. I create a list called fam, and I print it out, and we can see fam printed out here. So there's 3 print actions here, and so you can see the result of each of these things. I create another reference. I say second equals fam. Okay, so because I'm using an equal sign here, this thing, second and fam, both point to the same object in memory. They're pointing to the same object in memory. And so what I'm doing is, in this operation, I'm going to change the 0 index item in the list, okay, which is currently Liz. I'm going to change that to sister. And so I can say, okay, well, what does the list second look like now? Okay, well, the 0 index item in the list is now sister. All right, so it reflects the change that we've made here. However, because both second and fam are pointing to the same object in memory, when I ask print fam here, we can see that fam has also changed. Okay, and it's not that fam has also changed. It's just that fam is pointing to the same thing. So when we ask for that thing, we see the same value, right? Fam and second are basically 2 names pointing to the same object. Here is an alternative, and here the only change between these lines of code and these lines of code is that when I write second equals fam up here, whereas over here I have second equals, and I put fam and I do slice everything, right? So I do the square brackets and I use the colon, and so that creates a slice. It creates a slice from the beginning to the end. I didn't specify any numbers here. So this will create a copy. Okay, this will create a copy. Alternatively, I could have done second equals fam.copy. That's another way of creating a copy. And now, when I change the 0 index item to sister, it affects only the second, which is the copy, and it does not affect the first, because second is a copy. So they took the object fam and it made a copy of it, and so now these names are pointing to 2 different objects in memory. Okay, does that make sense to everybody? The difference between what's going on? All right, here's another example. I've got I take fam and I make another copy, and here I'm going to print this out. I change one of the values to 1.65, and we have that, and we can see that the original value of fam remains unchanged. Another way I could do this is I can call lists. I can take the list and I can throw it into list. So these are all just ways of kind of making a copy, and we can see that this also we can change the values here, and the original list is unaffected. One thing about list slicing is you can use list slicing in conjunction with assignment, and it will change the value. So this is just assigning values directly to a slice of the list. Okay, this isn't really related to the copying aspect. Okay, so here are a couple methods related to lists. All right, we have list copy. And that's equivalent to kind of assigning a new thing of a : : and then list.append, okay, list.append basically adds some item to the end of the list. So here, if I have this, I can do the list name, so fam.append, and then I want to tack on the character string me. Okay. And now my list indeed has grown by a length of 1, including the new item that I've given to it. Okay. And so here, one thing to note is that, you know, if you were to oftentimes if you were to do something like this in R, what you would have to do is you'd have to do an assignment operation, right? You would take fam, you'd maybe combine it with something, and then you would have to assign it back to itself. But here we are actually modifying the object itself. We're not returning a modified copy. We are returning the object itself. So the modification happens right here. Okay. You could also use plus. Okay. Plus will take the list and append or basically add a thing there. Okay. But this is an operation. And so notice here, if I want to actually save it back to fam, I have to assign it, okay, using the equal sign back to fam. So the list method .append modifies the list in place, that object in memory. This creates a new object. It takes fam, it adds 1.8, but it creates a new object. And if I want this to be called fam, I have to assign it back to fam. Okay, so note that this needs to be captured or assigned back to whatever name we're doing. Okay, but this is a shorthand of kind of appending things. And the nice thing about this is you can append a list of arbitrary length here as well. So the plus is a nice thing. Okay, here I can do fam.append, putting in my name there. Here, I am appending a list with 4 items in it. Okay, and notice what happened to the list. Okay, we now have the list contains everything that we have, and this list of 4 is now included as one item. Okay, it's embedded, it's nested in here. It's not, we didn't take the 4 elements and add them individually. Okay, this has a length of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It has a length of 12, not 13, 14, not a length of 15, right? It's just that the 12th item is a list of 4 itself. However, when you use the plus operator, it'll concatenate the list, right? So fam is a list of 8 here. This down here is a list of 4, and when I combine the 2 together, now we have a list of 12. So there is a difference between using plus and append if you're going to give it, if you're going to provide a list there. Okay, but again, when you do the plus operator, that object, the fam object is not modified itself, right? So the fam object still contains only the original 8 values. If you wanted to save it, you can save it. You need to have to explicitly assign it. All right, there is something, there's a distinction between a shallow copy and a deep copy. Okay, list.copy and list bracket : basically a slice containing everything. These are both going to create shallow copies. A shallow copy creates a copy of the list, but it does not create copies of any objects that the list references. Whereas a deep copy will copy the list and create copies of the objects that the list references. So let me just give you kind of an example here. All right, here I have list A, which consists of the character A, 1, 2. I have list B, which consists of B and numbers 3, 4, integers 3, 4. And I have list C, which references object A and references object B. Okay, here I'm going to say D. D is a shallow copy of list C, and E is a deep copy of list C. And in order to create a deep copy, you have to import the copy module, and you use copy.deepCopy and the object you want to copy. So I'm going to do copy.deepCopy C. So D is the shallow copy and E is the deep copy. Okay, so notice what happens to here. I'm going to append just X to C. And append X to C. So what does C look like now? C has the list A, the list B, and now object character X, okay, or string X at the end. So list C is a length of 3, list A, list B, and character string X. Okay, whereas D and E are both unaffected. These are both copies and they're unchanged. Okay, this barely fits here. All right, let me append the character Z to list A. Okay, I'm going to append a Z to list A. So when we ask for what does C look like, so remember C includes a reference to list A, a reference to list B, and the character X. So list C now has list A that has been modified to include the character Z. List B we never touched, and it has X from before. Okay, list D, which is a shallow copy of C, okay, contains this reference to the same object A. So this object A is the same as this object A, which now includes the Z here. Okay, and over here we have B, the reference to B, which we never touched. Okay, whereas list E, okay, list E, can't do it. List E, we created a copy. We created a copy of the object A, right? So the original list C had a reference to object A and a reference to object B. And we created a copy of that object A. And so when we appended Z here, A.append Z, okay, this object A is different from this list, which is a copy of that list A, okay? Whereas these two things reference that same object. I hope that makes sense, what's going on here. Okay, the difference between a shallow copy and a deep copy. So the shallow copy copies the references, creates a copy of the list, but and keeps the original references, whereas a deep copy will make copies of any objects referenced. Okay, there's a few more things. We have list.insert and list.extend. Okay, so list.insert is just going to insert an item at some given position. So I is the index, X is the object you want to insert. And then you've got list.extend, and this is going to be some iterable thing. Okay, so for example, if I say, here's our list fam, and I want to insert the character string Joe at index position 4, that's going to get inserted at index position 4, which is the fifth element, right? So 0 index 0, 1, 2, 3, 4. Joe gets inserted at index position 4. Okay, and if it's easier to think of it, you can think of the 4 as inserting it at the 4th comma, right? So 1, 2, 3, 4. It's going to go after 1.68. Okay, if I put in an iterable, like a list here, trying to insert multiple items, it's going to insert the list itself. And I think I had something, you work on something similar to this in your first homework assignment. I said, I didn't want this. I don't want these items here, okay? And if you try to insert multiple things, it doesn't work, okay? It complains and says you're trying to put in more than one object here. It only accepts two arguments, a position and an object. And here I'm trying to give it more than that. And it says that's not allowed. Okay, but what we can do is we can do extend. So this is kind of like using the plus operator, and it extends the list by iterating it, by going over the iterable rather than just appending this list of two as one object. It extends the list. So it's kind of like the plus, but it modifies it directly. So you don't have to do fam equals fam plus the list. Another way you can do it, if you wanted to insert this iterable into index position 4, okay, you could use list slicing in conjunction with assignment, okay? And so here, if I want to insert these two things at index position 4, I can do, I can slice 4:4, which is nothing here. It's just this fourth comma, but we can insert the list there, and we get, I think, what we want. So this is kind of like a little mini solution to that first homework problem. Not the first homework problem, I think one of the later problems in the first homework. Okay, a few other operators, a few other methods that we can use with lists. We've got list.remove, list.pop, list.clear. Okay, remove just will remove the first item in the list where the value is X. If there's no item with that matches X, you get an error. List.pop will remove the item at position I. If you don't specify anything, it's going to pop the last item in the list, and it returns that object. So you can actually, if you do list.pop and you assign it the object that was removed, it modifies the list, and that object that was removed gets returned as a value. Okay, and then you can also delete everything by doing list.clear. So that will clear out the list. Okay, so here, if I start off with this list and I say remove Liz, we've removed that. Okay, and so it just removes it, and it keeps going on. Here's the original list again. I'm going to do fam.pop. Okay, so we're going to pop, and by not specifying anything, the default behavior is to pop the last item. Okay, so it's going to pop this 1.89. The new list now no longer includes this last object, but it also returns that object. So you can remove it and do something with it. So if you need to use this object, it's kind of like, I guess, like dealing out cards, right? So if this represents like the original deck of cards, when you pop, it's like dealing off a card. And so what remains in the deck is one less, but you can also take that item that you removed and do something with it. Okay, you can, the default behavior is to pop things off of the end, but you can say, I want to pop the 0 index. And so here we're going to pop Liz, and you can specify any other index as well. But pop 0 will make the list and kind of behave like a queue, whereas pop will behave like a stack, right? So the stack is last in is the first out, whereas the queue is the first one in is the first one out. Okay, and then lastly, you got fam.clear, and that just deletes everything out of the list, removes all the items in the list. Oh, I've completely forgotten about view quiz answers, and I don't even remember what they are. I got to look these things up, so just give me a moment. Sign in. Okay, week 3, Wednesday. Okay, your first view quiz answer today is the letter B. B as in bear. B as in bear is your first view quiz answer. B as in bear. Okay, a few more list methods. List.index. So we can ask, what is the index of the object with the value Emma? Okay, so if there were multiple things in here, it would just give you the index of the first item in the list. All right, so here it says the first time we encounter Emma is at index position 2. If we ask which index position has the value 3, it's going to come back with an error, and it's going to say it doesn't have that. Okay, there's no 3 in the list. There's no index position there. All right, here's a different example. Here I've got a list, and we can say how many times does the object character A, or string A, appear in this list? And it comes back and it says it appears 3 times, and that's going to be list.count. And turn the number of times object X, whatever it is, appears in the list. Okay. Here I've got a list of lists, and so if I say, does character string Emma appear? It does not. Okay, it does not appear as one of the objects, right? The original list here, it has 4 objects in it. Okay, and one of them is not the character string Emma. It does contain a list object that contains Emma and the value 1.68, and that's at index position 1, and it appears 1 time. So the count there, but it doesn't kind of try to trace down into objects and objects here. Okay, list.sort will sort the list in place. Okay, and list.reverse, the list is changed in place. So if I do fam.reverse, it changes the order, it reverses it, changes the order. Here, if I try to do fam.sort, it returns an error because it says I can't sort when you've got a mix of string values and character values. Okay, or string values and numeric or floating point values. Okay, it says I can't sort those things. But if you just have some numbers, okay, and you sort them, it can do it. All right, and you can mix integers and floating point values, and it's got no problem there. You can ask, what is value 4? It's a float, and that's fine, and the rest are integers. Okay, you can sort them in reverse order, and it puts them in reverse order. Okay, so that's sorting, and this sorts the list in place. Remember, lists are mutable. You can modify them in place. Here's a new list. Okay, I'm going to call this sum digits. Sorted sum digits returns a sorted copy of the list. And I think I had, one of these slides and one of the other lectures, I talked about naming conventions. And so back here, we have list.sort. This has an action verb, and it modifies the list itself. It takes the list and sorts it. Sorted gives us a sorted copy. Okay, it's a little bit more of an adjective form of the verb, and so it's not an action verb. It's the verb in adjective form. I guess the participle. I guess past participle, is that what we call it? I don't remember. And so this gives us a copy, and so it gives us the values in sorted order. But if we ask what is the original list is unaffected. Can sorts do alphabetical sorting? Absolutely. I did. Yes. Well, anyway, so if you have character strings, I don't have the example here. I think I've got an example later, but it will sort. If a list has only character values or string values in it, it can sort it, and it'll it'll do it in alphabetical order. And I think, let me just verify. Okay, so we've got that, and we'll do I'll do sorted L1. And I think all of the capital words come before the lowercase ones, but I could be wrong here. Yeah, okay. So alphabetical sorting, the capital letter A comes before the lowercase letter A here. And so this is the list in sorted order here, if you got just characters. Oh wait, no, this is the notebook. So when you're creating a Jupyter notebook, you can, with the if you do view show right sidebar, you can specify where you want new slides. So my presentation here is based off of a Jupyter notebook, and you can say, I want a new slide type slide. Fragments are things that show up on the same slide, fragment. And then here I have, I want a new slide here. And so you can kind of specify all of this stuff here. It's a pretty nice thing. And then you would you use NB convert to create a slide presentation. That's a side thing. It's not important, but I do want to show you some of the tools that are being used here. Okay. All right. A string. So we can think of this. All right. A string is also a sequence of characters, right? So the way, a list is a sequence of kind of objects inside a list, and a string is a sequence of characters. And so here I've got fruit, and I can say, what is the character at index position 0? And that's going to be the letter B. Okay. And what's the character at index position 1? It's the letter A. What's the character at -1, right? And so basically all of the subsetting rules that we have that apply to lists also apply to the characters in a string. So when you do -1, you get the last letter, which will be the character S. Okay. And if you say, well, what's at index position 1.5? It says you can't do that. You can't give me a non-integer value here. Okay. You can ask the length. The length will tell you the length of the string, which is, how many characters are in the string. Just like you can use len on a list, and it'll tell you how many items are in the list. You can subset strings in the same way, or using slicing, just like you would slice a list. Oops. What did I do? Oh dear. Okay, so here I say slice it from position 4 to 9, and we get EFGHI. How do you do this for a list of character objects? So wait, so if you have a list of character objects, it works just the same way, right? So here I have a list of character objects. I can do L1, and I want from, say, position. So this is, remember, sorted does not affect L1. So if I ask what is L1, it looks like this. And I can say I want, slice from position 2 to 4. Okay, so I can do 2:4. It will give me back these two values here. But I can take object apple. Okay, and I can take this thing, and I can slice the characters from, say, position 2 to 4. we will get the characters PL out of Apple, right? So I can take that object at position index position 2, which is Apple, and then I can say slice out the characters, treating this as an iterable, slice out the characters from index positions 2 to 4. I want the last 6 characters. We'll do this, -6:. You can also, you can treat it as an iterable, okay, much like you would a list or a tuple. And you can say for X, this will be for character X in string 0:5, which will be the first 5 characters in here. Okay, so it'll be take character X and print X plus the exclamation point. And now, we're enthusiastic about the alphabet A, B, C, D, and E. Okay. Strings are immutable. So unlike lists, where a list, you can take the list and with the list, we can say L1, again, here's L1, and I can say, L1, I want to change the item in 1. I want to change it to the character B here. All right. And if I ask what is L1, we have modified what the item is at index position 1. Okay. Whereas when you're working with strings, you can't do that. Okay. You can't just say, you know what, the first character in my string was an A, and now I want to change the first character in the string to a B. Okay. So when you create a string, you create an object, but that object is immutable. If you want a different string, okay, or if you want like the same string, but you just want to change one of the characters, you have to create an entire new string. You have to create an entirely new string. So if you wanted to do something like that, if I wanted the first letter to be a B instead of A, B, C, D, E, F, G, but if I want that first character to be a B, I can do that. But here I have to create an entire new string. And, you have to be a little bit creative, whatever it is you're trying to do. But you cannot modify strings in place. Strings are created and you can iterate over them, but you cannot do anything to change their values. Okay, here's a few methods that you can apply to a string that, just all happen to do stuff with kind of things with characters. So, before I forget, let me go ahead and give you your second view quiz answer today. Today's second view quiz answer is E. E as in elephant. Okay, E as in elephant is your second view quiz answer. All right, so here is a string. It says Stats 21, Python and Other Technologies for Data Science, the name of our course here. And it's just some string methods. You can take the string. So notice the way this works. The string here is called, given the name. And so I'm going to do name.upper, and it takes all the characters and makes them uppercase. Name.capitalize, and it just takes the first character in the string, makes it capital, and it turns every other character into lowercase, if we can do it, right? So the original string had all caps STATS, and then this stuff was all lowercase. So that's capitalized, just only the first character is capitals. Okay. Title case is every character after a space. After a space is capitalized, okay? Which will capitalize the P, the A and the O and other, the T and technologies and whatnot, okay? So this is not quite, I don't know, like the rules for making titles in English, right? I think in English, the conjunctions and articles are generally not capitalized. And I don't think prepositions are either, whereas nouns and verbs are capitalized. I don't know. I don't remember all the rules, but generally you would not capitalize the A and stuff like that. Lowercase turns everything into lowercase. And again, all of these things just return new objects because strings themselves are immutable. So these all return new objects, and the original object name is unmodified. If you want to count how many times a letter appears you can, here's one way to do it. You can iterate, right? We can start off with count equal to 0, and we can iterate for each character or each letter in the string. And we can say, if that letter is the character E, then increment our count, right? I could have done plus equals 1, and we get back 5, okay? But it's much easier if you just do dot count. You can take the name and you can just do dot count, and this will also say, oh, there are 5 instances of the character E. It is case sensitive, although I don't have, in this thing, I did the character E. You can ask what is, just like the list, we can say, what is the index position of the character capital A, right? And it's going to be the first instance of it. So it's an index position 2. We can ask some Boolean things. Does the name end with the character K? And this comes back false, right? It was it's data science. It ends with an E. So it doesn't end with a K. Does it end with an E? That is true. These are Boolean things. Does it start with a lowercase s? The answer is no. Okay. You can also create strings that are multiple lines using triple quotes. So if you do triple quotes, you can enter strings that are multiple lines. It doesn't look like much is going on here, but all 3 lines are present. It's just, you can't, it's hard to see them. But when you use your mouse to highlight it, these invisible characters do make an appearance. You can do, you can take a character string and call strip. Okay, this is another method that deals with strings, and it just removes any kind of leading or trailing white space. Obviously, it does not remove all white space. It leaves spaces that are intact, between characters intact, but it's just kind of the leading white space, the trailing white space, which includes new line characters. It will trim them off. Okay, again, the strings are immutable, and if you ask what are the strings, it will show you that here's the original string. And this is one of the differences between print and just calling the object by name. Okay, so when you call the object by name, you'll get kind of these new line characters appear. So this is to show that, oh, you know what, there's a new line character after the N, here's a new line character, and there's a new line character, at the end there. So we have 3 new line characters, and they show up here. And when you print them out, it prints the new line characters as new lines rather than this /n business here. Okay, and the original string is still has the white space there. Okay, string.split by default will split on a space, and it will we take this and we're going to say, all right, what it will do is it basically looks for spaces in between characters, and it returns those objects there. Okay, so the name.split is going to return a list, and it says I found this character MILES, and then there was a space, and then I found the character CHEN, and it puts those in a list here. Okay, here's a string 2, 3, 4, 7, 8. So these are not numbers in a list, they are character strings. There's numeric values here. And so I can do string.split. By default, it splits on spaces, and there's no spaces here. So it just returns a list of length 1. And the object in that list is that exact string. I can say, you know what, split on the comma. Split on the comma, and so now I get a list of length 5 with characters 2, 3, 4, 7, and 8. Okay, now I can't do any kind of math with this. If I want to do math, I have to convert these into integer type. Now, if I take the list here, and if I just did int on this, it's going to complain. So let me just kind of show you here. So here is, let's call this L2. All right, so here's list 2, L2. And if I just say do an int on L2, it doesn't like that, right? It says integer argument must be a string. Okay, so I can do like L2 object 0. That's the string with character string with the number 2 in quotes here. And I can say do an int on L2 on object 0. Okay, and this will convert to the number 2, and then I can do math with this thing. Okay, I can't do math with this, right? If I tried to do this, if I tried to say, let's do, what do I get? Instead of adding the 2 and the 3 and giving me back 5, it gives me back 23, okay? Which is probably not what I wanted. But what did I do? If I do this, and I say convert this into an integer, and convert this into an integer, then I can do that, right? 2 and 3 will give me back 5. So I can do the math here, whereas this is probably not what I wanted to do. The quote math there is not what I'm looking for. So we'll learn about list comprehensions later, but what you can do is you can say, all right, take this numeric string dot split. Okay, this part gives me back this list. And I can say for every element in this list that I have, okay, for each X in there, make it integer X, right? And this whole thing is enclosed in a list. And so now I get a list of integers here. This is called the list comprehension. We'll get into it, but it's basically like doing a for loop. Okay. Here I am doing the same thing, but using a for loop. Okay. And so I start off by creating an empty list. I iterate over it. I say for each X in this numeric string split, and append X converted into an integer. Oh, and let me go ahead and give you your third view quiz answer. Today's third view quiz answer is the letter C. C as in cat. C as in cat is your third view quiz answer. Is.alpha. Is.alpha means does the character string, so this is another Boolean thing, right? Anytime you have an is dot or dot is something, is going to return a true false. So is alpha is going to return true if the thing only has characters from the alphabet, right? So if you do stats 21 Python and other technologies, it has spaces, which aren't alpha, and it's got digits, which aren't alpha. So this is going to come back false. But if you do A, B, B, A, A, Z, lowercase and capital, and you say, is that alpha, only alphabet characters, that can come back true. Okay, if you put in a number in there, a digit, it comes back false. You have other string methods. All right, so here's a few lines from a song, and it's a long string, so it comes in triple quotes. Okay, and this changes the nature of the song, but you can turn it into uppercase, and now we're shouting out these lyrics. We can split it, and it's going to split out the spaces and the new line characters, and we get, a big list. And that's, how would you split at every character? I gotta think about that. I think you could just do a list comprehension here. Let me so here's the this, and then I would just do a list comprehension, and I would just do X for X in long string, and I think this will take every single character and put it into an element in a list here. It's a really long list now, but you can do it. Okay, and that's going to put in the spaces as well as the new line characters. Okay, what type of copy is it when you use .use.upper and sorted? So they're just copies of the string. So strings can't contain references to other objects. So there's no distinction between a shallow or a deep copy when you copy a string. So the shallow copy, deep copy only makes a difference if the object contains a reference to another object, but strings, it only contains string things, so there's no difference there. So here I did string.split, and it split on the spaces and the new line characters. You can also split on new lines, and so it only splits on the new line characters. And so now we've got each line gets its own whatever element in the item in the list. We can ask how many times did the character E appear in the entire string, and that's fine. Okay. We can search for a letter, right? And one way is we can write this function. All right, so take this and this long string, whatever it is, and search for the character. And we're going to start off at index position 0, and we're going to just keep going until the index position reaches the length of the string, until it reaches the last character. And we're just going to ask if the string at that index position is equal to the letter that we are searching for, return the index. And when you return the index, it's going to come back and end. Okay. And if it doesn't find that, then we increment to the next index position. And we keep going, doing this until we reach the end of the string. Now, if we reach the end of the string without finding this letter, then we're going to return -1. So we can say, all right, tell me where is the character T? And it goes through, it starts off at 0 and it encounters the T here, and that's at index position 7. Okay, you can, so this is one way to kind of implement a finding of a character. There's already a method that does it though, okay? There's already a method, and we can say just take the string and do find, right? Find this, and this is going to return a T. Now, and we say, well, I thought I saw something similar already, right? We had dot find and we had dot index, okay? And both of these things, we say, what is the index position of the character T? And it also comes back 7, right? And index position and find, they both kind of give us the first instance of this thing. So it feels like we're doing the same thing, but there is a distinction, and it's how we handle characters that we can't find. So if we ask, where is the $sign? Well, there's no $sign in this thing, okay? So find is going to give you back -1. -1 means it couldn't find the $sign here. Whereas if you say, give me the index position of the $sign, this comes back with an error, okay? Because it's going to, so here you're basically saying, I need the index position. And now it says, well, there's no index position because it doesn't exist, right? So one is kind of just like asserting, you're telling it, give me this thing, I need it. And Python says, well, I don't know where this is. And so it gives back an error. Over here, we're asking, can you find this? And if it can find it, it gives you back the thing. And if it can't, it comes back and it says -1. So it's, do you want, if this is like a mission critical thing and you need this thing, then it makes sense to use the index, and you want the code to stop when it can't find it, right? And if you don't want it to like stop, and if you want it to keep doing, if you can't find it and you have something planned for when it can't find it, then you use the find. All right, we got a few more operators, and I'll go through this quickly. The in operator is going to just return true or false, whether, if it can find it. So A is in bananas, nan is inside bananas, bad is not inside bananas, okay? You can do string comparisons, and this basically does stuff in alphabetical order. So does A come before B? That is true. Does lowercase a come before lowercase b? That is true. But one thing that's a little bit strange is all the capital letters come before all of the lowercase letters. So capital Z comes before lowercase a. Okay. Digits come before the letters. And these are treated when you do the digits, they're treated as characters. So 1 comes before 101. I'm sorry, not 1 1. 1 1 comes after 101. Okay, because it's looking at the 1 0 and the 1 1, and so this is going to come back as false. Okay, and then there's also just this weird arbitrary arrangement of the symbols. And so here I've just got kind of I just put in a bunch of characters from the keyboard, and I said, hey, what is this if I sort this? Okay, and if you sort the string, this is what you get. Is it according to ASCII? I don't know what the order of characters are in ASCII, so I don't know. I don't know the answer to that. Maybe. I'm not sure. Okay, that's it for today. I will post a new homework, and I'll also post some data camp homework. And so just keep an eye out for that, and I'll give you a heads up. All right, other than that, have a good rest of your day, and we will see you guys on Friday.